All right, hello everyone. Welcome to, someone can hear all the typing. It's Tom number 1. He is joining us for the lecture today because Tom number 2 had to do something else. That is confusing, I agree, and also because I swap around number 1 and number 2, so no one knows which one is which. We just kind of hope for the best. But welcome to lecture 5. Week 3 has started. Super exciting. Don't throw me off the scent. Oh my gosh, is there more than 2 Toms? If we ever hire another Tom, I'm going to lose the plot, I think. And if his surname starts with a K, then I will definitely lose the plot. It will be too much for me. Too many Toms. Okay, so who's typing so fast? It's definitely Tom, and you'll hear the keyboard going through the lecture as well, no doubt. Every time we're in the meeting, I have to ask Tom to pipe down that keyboard a little bit because it's very loud. Anyway, so today we're going to be doing some awesome stuff. Let me go back to my lecture notes. Here we go. Oh, someone's referring to the 3 Spider-Mans. Oh, that is that meme exactly, and me just going Tom and them going which Tom and Tom. I should make it an exercise, I think, maybe for a lab in a later week, just trying to find the right Tom. Okay, well, welcome. Did we fix the air conditioning? We will find out in exactly 1 hour when it switches off, and you start to see me sweat profusely. So it'll be great. Super fun. I feel like I'm getting, yep. Anyway, we'll see how that goes. Hopefully well. But hope everyone's had a good week, is staying dry, not in the flooding zones. That will be nice as well. And today, well, in the last lecture, what was it? Oh, it was last week because already a weekend has come and gone. So last lecture, we played with some decision making using if statements. We did loops. So we did the while loop, and we're going to keep doing loops as well. We're going to keep doing if statements now as well. That's it. They're forever ingrained in your the way you have to write code now. And then we talked about scanf a little bit. We talked about how eccentric it is, and all the some of the issues that we have with scanf. And we also started to learn a little bit about structs and how exciting they can make coding. I don't know. I think everything can make coding exciting. So apologies. I'll be like, an int variable. This is super exciting because you can have an integer overflow and underflow, and then a whole bunch of exciting trivia there. So that's super exciting. And then today we're going to have a pretty chill lecture. We're going to do style finally. We're going to do quite a bit on style. I'm going to show you some bad style. You're going to basically throw eggs at me and try and fix my bad style to make a good style. Hopefully, I was just telling Tom earlier that I got so excited when I was doing the bad style that I literally don't know. I've completely ruined this piece of code. It is looking pretty bad. So apologies in advance. Hopefully we can fix it without actually having to just remove the file and start again. And then we're also finally going to talk about functions. So you've heard me say the word functions quite a bit. You've heard your tutors say the word function quite a bit. And so you're all probably wondering, what on earth is a function? What is it actually, except for the basic thing of it's just something that does functions. So today we're actually going to learn a little bit more about functions, or a whole lot more. I'm not sure. We'll see how the hour goes. And then at the end of the day, we are also implementing a new ticketing system, a fast pass system. So it's like you're at Disneyland, but you're not. You're actually in COMP1511, getting some help. So, but equal levels of excitement. You could be on a roller coaster, or you could be coding. So equal levels. Better than Disneyland. I agree. So at the end of the lecture today, Tom is just going to run through 5 minutes. He's going to run through the system that we're going to use, Hail, and we're going to, introduce you to it, because that's how you'll be able to grab fast passes for the rest of the term to be able to attend a help session and get some help as well. So it means that hopefully you'll be seen a lot faster, well, in such a way that you're not actually waiting for 2 hours, especially around assignment deadlines. So we're really trying to make sure that everyone gets all the help that they need in kind of a bit of a more reasonable time frame as well. Okay, so lecture code. Tom, could you please paste into the lecture chat the link for the live code? That would be great. That's going to be today's lecture. And the code that we will be doing today. Lecture code's not opening. Oh God, did I forget to chmod it? I forgot to chmod it. I'm sorry. Don't look now. Don't look. I thought I did. You know what I did? Can you open the week 3? I forgot to link it. Did I forget to link it? I forgot to link it.
Do you want me to?
Yes, please.
I'll go do that now.
Okay. Let me reveal week 3 as well. Here we go. Here we go. But whilst Tom is linking that, for me, this is exciting. We've got a lot of puns going. I do love a good pun. All right, let's do it. You see, it's because I was so worried that you'd see this code that I was like, please don't. I won't show it to you, but I will show it to you. Here we go. Tom's about to make it available. Whilst he's doing that, let's talk about what is style and why do we style. Who'd like to pop into the chat what they think style is? How do they feel about style? What do they feel about style? Who wants to style? What should we style? What style when we talk about code? And I've sort of been mentioning it a little bit here and there, but we haven't really focused on it. So it's time to give us a little exciting preview of style. Someone's saying they're not very stylish. No, everyone's stylish. Everyone's got their own style. Lots of people would say I'm not very stylish, but that's okay. It's my own style. How the code is structured, the way you format your code, fashionista code. How taboo is it to bring a custom keyboard into the lab? Well, I bring my own trackpad into the lab space, so I don't know. I feel like I also have I only like a specific keyboard, so but this lab has the keyboard that I like, so we're okay. Wearing socks on Crocs, is that stylish? I'm not sure. The way we write code makes your code easier to read. Yes, fantastic. Enforces consistency. It does indeed, which makes everything a lot easier to read. Coding, but it's art. Well, coding is art. It's a very sort of creative space. The way you write code, absolutely. And making code easier to read when you need to change code. These are fantastic. Code should look... Yep. I don't know what anyone's saying there. A way to feel superior because your code is better styled. I guess. Shall we make a custom keyboard lab week? Oh gosh. Okay, I'll just carry around my keyboard. Why not? Thank you. Someone said they like my shirt. I appreciate that. This shirt is about 20 years old, but I'm very spare with wearing it because I like it. All right, improves readability, which helps with future maintenance. Filling my boots with water to train my legs. I don't even know what that is. Not about styling code. Excellent. Yeah. Okay, fantastic. So style is pretty important. It's when we really, make sure that our style is readable by another human, because really, oh my God, please don't say that shirt's older than... That shirt is older than the people in the chat. But it looks great. This shirt is... Apologies. Good. That shirt is as old, if not older, than most of us. I'll take it back. This shirt is 15 years old. We'll go with that. Okay, so we really want to make sure that our code is styled, because what that means is that we make it easier and more accessible for other people to read. And what happens then is, you're not always going to be the dictator over your code. Other people have to participate, or other people have to read your code. Sometimes you're working in a team, and so you all have to be working together, and you all have to be able to read each other's code. So you really want to make sure that your code is styled in such a way that you are able to actually, read someone else's code, but also read your own code. If you write bad code and you come back to it a few weeks later, you might not even know what you've written. In fact, the piece of code that I wrote for this particular exercise is in fact so bad that when I looked at it 2 hours ago, when I stuffed it up even more, and then when I came in here and opened it, I didn't know what I was talking about. So, all it took was 2 hours. So you have to be pretty careful. So the code that we write is really for human eyes. So it's for a human to be able to read, for a human to be able to understand, and we want to make our code easier to read, easier to understand. Also, if you have neat code, then you're able to have faster development time, less likely to make mistakes. So you're more likely to write nice code straight up, because you can see where things indent and where your where your loops end. And so perhaps where you've made a mistake, you'll be able to see it much faster. So coding should always be done in style, as everything really. You should always do everything in style. Okay, what's good style? Let's talk a little bit about good style. Okay. Indentation and bracketing. I'm sure that you've all, maybe when you've just first started to code, you started to write without any indentation, maybe no brackets either. And that would make it very, very hard to read. Sorry, apologies. I really love Silicon Valley, which is just really, I don't know if anyone's seen the show. Is it too old? Do people still watch it? Is it a thing? Maybe it's a thing. Tom's saying it might be a thing, not sure. But if you've ever seen it, there was a whole episode where they were like, they were talking about someone that they were hiring, and they were like, we can't hire him. He's basically crazy because he uses spaces, not tabs. And I think I couldn't stop laughing for about, I don't know, maybe like a few days. And my partner was just kind of just going, I don't get it. What's so funny? So now you'll be able to really feel that joke so hard. Tom's just written on the board, I love spaces. So he's about 5 minutes away from being kicked out of this room, because tabs are obviously superior. So also, it's the way that we name our variables and functions. So is our code, can we read the code without sort of any comments and know what it says based on the names of the variables and names of the functions? So can you give away what's going on by giving your variables and your functions good names, but also structuring your code? So how much nesting have you done? And nesting is not a good thing. So if you've got an if in 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 an if, and you have all done an exercise, I believe in week 2, that had a lot of ifs and a lot of things happening in the exercise. So things like that make your code a lot harder to read as well. So repetition as well, and we will learn what to do with that repetition in a brief moment. In the second part of the lecture today, we're going to learn what to do with repetition and how to take care of it. So that will be something we'll talk about as well. What can we do with this code that is constantly repeating? Comments where comments need to be. So almost every lecture I tell you, please don't look, don't, when I'm commenting my code and I'm writing a ridiculous amount of comments, that's not how you should be doing your code. I'm only doing it because I'm trying to show you different things in the code. So do not do that. If you have excessive commenting, it makes your code harder to read. You don't need to explain every single tiny little thing that you do in the code. That is not necessary. because your code should be self-explanatory as well. And we will guide you on where you should be using comments. So usually you use comments on top of functions to say what this function does, very brief description. We'll talk about functions in a second. But also you will use a comment in your code if something is really complex. If you're performing something complex that might not be obvious what you're doing straight away, you might write a very brief comment about that. So that is really kind of when you will be doing your commenting, and you do get marked on style in your assignments. And we provided a rubric as well in the assignment 0 description. It's going to be a similar one in assignment 1. We'll talk about assignment 1 next week, but slightly different because we're going to include commenting and a few other things that assignment 1 will have in there as well. So when I'm reading your code, I should be able to understand what that code does just from the structure and the variable names. And I should be able to really get an idea, very, very quick idea of what's going on, really, just by looking at your code. Okay, let's have a look at some bad style. Okay, fine, it's time. Let's do it. Okay. Bad style, let's do it. Okay. So if you want to, feel free to open it on your own computers. I hope your computer doesn't crash because they're like, ugh, that's horrible. So this is a piece of code that, I don't know, I introduced a lot of errors into as well. So now I'm going to open it to you all. And if you shout, let's start from the top, and maybe we will do... what is wrong with this? What can I fix straight up? I don't even want to compile it. Do you want me to compile it? It's going to be pretty bad if I compile it. Should we compile it? Well, let's just compile it so we can see what it does. What are we doing? Bad style.co, bad style. Okay, so, okay, quite a lot happening. Quite a lot of errors up there. And if you ever see that you get this many errors when you compile something, don't start looking at the bottom or in the middle. Kind of look at the first one and see if you can fix it. And the first one, I would be able to fix it. Someone's saying just delete the whole thing at this point. This is how I feel because I went a little bit too hard and too strong. But let's try and fix it just so that we can see all the things you can do better. Okay, so let's talk about it. Okay, what can you see that is wrong in this first section over here? Yeah, I can see include should be out of the main. I agree. So hash include should not be inside the main. It should be outside the main. I'm going to move it outside the main. Okay. What else have we got? Bad style is using a light theme for coding. Oh, wow. Okay. I think it's actually easier to see. Maybe it's not. I don't know. I'm just trying to keep you all awake. Time for an exercise. Great. We're still going on that pun. Love it. Run style check. I don't want to. That's going to be really complaining about this. Yeah, someone said these small letters are not gonna. They're not gonna fly. They're gonna want to be big letters. Where should the struct be? The struct should be outside. Well done. I'm going to move the struct outside my main function. I agree. Okay. What else should... Anything else about the struct? Bad names, someone's saying? Absolutely. They're terrible names. I have no idea what's going on here. Yeah, struct should be... Someone's saying indenting the code. I love it. That is usually the fastest thing to fix something, is to indent it. Okay, no space between void and main. Okay, great. Colon, well done. Semicolon after structs. Yes, good, excellent. Good. The horrific indentation is epic. Thank you. I appreciate that. Okay, let's have a look. So let's see what we can... Let's fix the indents. Okay, so I'm just going to hold the chat for a second whilst I fix the indents. Okay, and then we can talk about all the other things that are here that are not... and look at this inconsistent indenting. We don't want that. I'm struggling. My goodness. Okay. Okay, just fixing it. I have no idea what's happening. Okay, here we go. It's very hard to see whether or not I'm inside or outside where I'm going. I fixed the first part of indentation. We can talk about it now. Okay, what else can we see that's not happening over here at all? White space. There is no white space anywhere. That's true. Okay. I'll do a white space there. Delete. Yes, completely delete. Someone's saying line 32. What's on line 32? There is something terrible. Terrible variable names. Yeah. I have breached the 80 character limit. How will I fix the 80 character limit? Excellent. Line 32 should only be one equal sign. What is it? Return 101. Indeed. What is it? I don't think it should be 101. What the hell is return 101? It's here to haunt you. Return 101. Okay. All right. The comments aren't in real paragraphs. I'm not sure. Line 18 and 19. We're going to have to call all of these things something else. Yeah, budget. Which one do we think is budget? So what would budget be if it's over here? If it's in capital letters, what do you reckon it would be? Yep, a constant. Okay. Good. Okay, so let's make, do you think one of these might be? Should I delete all of this rubbish here? Let's start to, or maybe I'll just do that because it's nowhere else. Okay, let's go budget here. Okay, so hash define, excellent. Okay, the struct is outside. So something else. So this struct is called struct B. So this is the definition of the struct. And here I'm declaring the struct. So really this should be that this first thing here is of type struct B. But yeah. Okay. What else can we see? What else? I mean, we can see a lot, but I actually only have one struct. This is the definition of the struct. This is where I'm declaring it. I just haven't initialized it. But it's very hard to see because obviously there's a lot happening. Can anyone see anything on line 26 that could really... Oh, someone, just as I said that, Jack was in the chat going, yeah, line 26, absolutely. What's wrong with this line 26? I feel like it's not really, we don't really want this. It doesn't really say anything right now. Yeah. So yes, well done. We want some single quotation marks. Excellent, because I'm using a character. So I want to put it in single quotation marks to say that I would like some ASCII. Excellent, well done. Okay, now what is this program doing? Can anyone tell me what on earth this program is doing from just reading some of this maybe? What do you think it's doing? So that we can start fixing the variable names. What are we doing? Yep. So Jeremy's saying we can break it into 2 printf statements. We can. Something about ice cream. I feel like that's the story of my life. My whole life is just about ice cream. How do I get the ice cream? How do I eat enough ice cream? Yep. Perfect. It checks if you have enough money for ice cream. Yep, calculating total money. Check if you have funds to buy ice cream. Yes. Yep. Ah, there we go. Someone's starting to fix my terrible variable names. It really should be a total, shouldn't it? Yes, someone said this is going to be an int total. So now I'm going to replace all of these ones. Let's see. And this line 37, look at this mess. We need a space here. And we need a plus here. And then we don't know what's going on. Yep, keep buying ice cream as long as I'm under the budget. Absolutely. So great. Good. Okay, should I fix the rest of the indentation now? Tom, your computer is delightedly unhappy.
It's always unhappy. happy with me. It's worked too hard, 18-hour days, you know.
What can you do? I'm sure I fixed up the... I'm sure I fixed it up. Okay. Right, bigger. Tom's just written me a note on the board, and this note is like font size 8. Okay, you don't have to make it font size 60, but okay, let's have a look. Excellent, excellent. Is it bad to use acronyms? It depends what, I mean, it can be, depends what you're doing. Line 37, would you need brackets? Where? Would you need a space? Yes, you would. Yes, you would. You would absolutely need a space. I agree. Okay, so what am I asking here? I'm asking here, how many scoops of ice cream and what flavor do you want? Okay, so clearly one of these is a scoop and one of these is a flavor. And then I'm trying to pop these inside inside the struct. So my struct, this is really a little bit rubbish in my struct over here. What is happening? Yeah, so lots of these errors are going to be compiler errors because I've actually got the wrong code in there. So we're debugging as well. So when you have bad style, what happens is that you can often also have compiler errors. So things like using, one equal sign instead of two equal signs, or two equal signs instead of one equal sign, those result in compiler errors as well. So they're not just bad style as well. Okay, so let me look at some of them. Okay, line 32, break it up into 2 if statements. Okay, I can do. Okay, let's do that. And I introduced another issue just as I did that. Okay, let's break it up. Okay, I've broken it up. Okay, one thing has been fixed. Okay, price, scoop, flavor. I agree. Price, scoop, flavor. Price, scoop, flavor. Love it. Okay, now this is a terrible name for my struct. I am not into it at all. Let's fix this name as well. So now that we know what is inside the struct, do we know can we know what to call it? And someone's saying line 34. Yep, well done. It's line 35. That's why I couldn't find it. Good. Okay, we can call it ice cream. I like it. Okay, so let's do struct ice cream. Okay, so have a look now. What is this called when I've just done ice cream? I've done it in camel case. And what do we tell you not to do? Don't use camel case. So let's change it to snake case. So I'm going to have a struct ice cream, and inside it is going to be a price, a scoop, and a flavor. Okay, let's have a look then. So then here, when I declare this struct, first, I don't know what first is meant to mean, but this is going to be a ice cream. Yep. So we've got a struct ice cream, and we're going to, I don't know, what do you want the variable to be? Yep. That's right. Oh, someone's noticed the variable count is not initialized nor declared. Yes, it is initialized over here and declared, but it's kind of done something here. But do we need it? Don't know. Don't know. Yep, so in here we want to have something that will name it. So let's call it maybe the bill, because that's going to be, so my bill is going to be made up of type struct ice cream. Okay, in total car loop, and I've got this int scan here. Okay, then some random int count. Who knows what's going on? And then we have, okay. Now, I've renamed the first, I've renamed it to be the bill. And the P, we've renamed it to be the price. So this is a good time to remind you that to access the struct, I use a dot to access it. So now my struct variable name is called bill, and I'm going to access the price member of it. And I'm going to assign $1.25 to it. Maybe just 125, 1.25. I'm going to just assign a decimal number to it. Okay, now in here, I've got on line 31. What's wrong with this line 31? Something is very wrong with line 31. Oh, someone's asked a good question. Is it bad style or just preference to put opening curly brackets on a new line? So, we have our own style guide in 1511, and we keep a compact bracket going, which means that we open our bracket on the same line as our statement, and then we close it outside. There are other styles that would have it on a new line as well. That doesn't make it wrong, but usually each company also that you will work for, they'll have their own style guides. And so we have our own style guide in 1511, so please follow our style guide. Because that's what we're starting to teach you. All right, so everyone is correct. I should have 2 equal signs. And so whilst that loop is equal to yes, well, I assume it's a yes, it's a Y, I'm going to keep doing something. Okay, yeah, I've got semicolon on line 19 because remember at the end of a struct, when we define our struct, we put a semicolon there because sometimes there is this other thing that we can do, which would put, which would put something here, and it might be a little word there, which is why we need to let everyone know that we finished. So we put a semicolon there. Yep, I sure can. Okay, so bill dot price. What that means is I have a variable of type struct ice cream, and it's called bill. That means the bill has 3 things in it. It has a price, a scoop, and a flavor. And so what happens is that I want to be able to initialize the price of the bill. And so I've said that the price of the bill, so my variable name bill, then to access the member price, I use the dot, and then accessing the price, and I've initialized it to be 1.25. Yes, I think that's a great idea. Okay, so how many scoops? Okay, so let's have a look here. Let's fix this. So I want to have some white space here because it is an absolute disaster. And I'm going to scan F. So look what I'm scanning. I'm scanning a flavor. Yeah, and I've called this bill. So remember that I use an ampersand when I scan in to go to the address of that particular thing. And here I'm accessing the member flavor. And here I'm accessing the scoop. Okay, so this is going to give me lots of these are going to lead to compiler errors as well, especially this one because my types are not agreeing over here. So what do I need to fix here? Because if you have a look, bill flavor is a char and bill scoop is a int, but I'm scanning for 2 ints really. Yeah, so the flavor is not an int. So this should really be a %C. It might be strange to ask for ice cream scoops first and flavor second. But, yep, we'll go flavor and scoops. Okay. Okay. Then I'm going to move this out and indent it out. Okay, this is a pretty terrible error message. So the reason I put this here is because please don't do, if you're going to do error messages in your code, please don't write things like error. Or even we had an exercise, program exiting with code 1. Please don't do that ever. That is bad usability because what is error code 1? It doesn't really mean anything. So the reason for that exercise was to get you used to using a return 1 and matching it up with the error code. But if you're going to say to the user that there's an error, we want to tell them what went wrong. Okay, so what went wrong here? You did not put in flavor and scoops or something like that, right? Doesn't have to be. Okay, return 101. Everyone's like, what is going on? So if there's an error, we might return 1. Yeah, we definitely don't want to return 101. I mean, we could, but it doesn't really mean anything if we return 101. Not in this. Is it bad interface design to ask scoops then flavor, then expect flavor then scoop? It is. It is actually very bad. Yes, it is. I see what everyone is saying. Here I've asked for scoops first and then the flavor. It is terrible. So, yeah, ask it the other way around so that the user inputs it that way. Okay, fine. I'll fix it. I'll fix it. That was good. Excellent. Let's do what flavor do you want and how many scoops of that flavor. And I've gone over. Okay, so what can we do now? People are saying I've got an infinite loop. Do I have an infinite loop? I might have an infinite loop. Is using returns bad inside your code?
Like multiple returns.
Multiple returns. Maintain the same size of font. Okay. My goodness, Tom just can't write in the same size. That is a very good question. That, oh gosh, I wish I could direct the camera to that on the board now. It's a nightmare. Okay, I will return to the return. Don't worry, I will answer that question in a second. Can you return halfway through the code? I can return halfway through the code, but we will talk about that in a second. Y is never changed. So look what I'm doing here. I'm saying printf, would you like to try ordering more ice cream? And you input yes or no. And then I scan in a character and I maybe place it into loop or maybe not. Oh, yes, someone's got it. I'm not really using this count plus plus at all. It's a little bit of an extra, so I'm going to get rid of it. And I'm going to get rid of it here as well because it's not doing anything. My indentation is still bad, so this is all very nice. Ampersand, I agree. Oh, just fantastic. Well done. Ampersand, I love that. Okay, great. So, yep, good. So we've got that. This is our way to break out of this loop. So we do have a way to get out of it. Okay, what else? Why do we someone's like, why do we need to change the return number each time we use return, or can we return the same number? Oh, that's a good question. You can return the same number if you like. It depends what your program is doing. And we are going to talk a lot about return in the second part of the lecture because we're finally going to do functions. So it's really going to be, it's definitely going to become a lot more obvious what you can return and what you can't return and why do you return anything at all. So don't worry, it's coming. It's coming. Now, this is still a bit of a mess. So I'm just going to indent a little bit, and someone is saying indent a little bit so that it's in the while loop. I agree. Now let me see, what do I need to indent? That's going to indent, this is going to indent, this is going to go. Oh God, look at this, it's got 2 spaces, dying. Let's tab it. Then here I've returned, then here this if belongs to that else. There's some random space in front of it. I'm going to get rid of that. I'm going to indent this because it's inside the else. I'm going to indent this because it's finishing my else. So look at how my they're lining up whenever I open and close. And then this is here, and my while, is that lining up with my while? Yeah, that looks like, I mean, it still looks terrible, but yep. Why is the while loop indented in the bill price? It could be because I'm wrong. Yes, I am. I'm 1 indent over. This is why this code is so bad. I over indented by 1. Yep. Thanks everyone. Yeah, that's right. Eggs being thrown. Eggs being thrown. Oh well, lucky it's raining so much I can just go outside to wash off the eggs. Here we go, here we go, here we go. Now I'm just doing crazy because I'm trying to make sure that it's all actually making sense on the indents. I'm not reading the chat right now. I will return to the chat in a second. I'm sure I've stuffed up the numbers somewhere. Trying. Not succeeding. Here we go. Ooh, that one was off as well. 1, 2, 3, 4. That looks okay. See you next year. I can press things, but this way I also gave it some white space so I can see how it's, I like to see where it's going, because when I do shift tab, I'm just as likely to get it wrong as well. Okay, so what have we got? What do we reckon? Is this looking good now? Well, this is still not looking good. We still have a random variable name here that we don't know. So let's try and fix this one up. And this one was cold bill as well. And this one was scoop. Oops, scoop. Okay. All right, so is that looking okay? Should we line 47 is off by 1 space. Ooh. Oh, it is too. Okay, very good. Should we try compiling it? And, if you have bad style, often you'll still be able to compile your code and run it. The problem is when you come back to it, you might not be able to read it. And this is how you introduce issues when you have bad style as well. It's very easy to make mistakes when you can't see what you're doing. Okay, so we still have something that's not happening. So what's happening here? In function main, warning, total may be used uninitialized in this function. So what do you think this error code means? And this is actually a bit of an error, bit of a really good styling, bad styling thing as well. People are very keen for a new line over here. Oh, there is a new line there. I could be on the wrong. Is it possible to compile everything as one line? Oh my gosh. Sorry, I'm having a moment just picturing it. Okay, yes, well done. Didn't initialize the total variable, and then I tried to access it for the first time uninitialized. Well done, everyone. And this is quite a common error. So you are going to see that one a lot, so it's good to know what this one actually is doing. And in this case, it's causing, so it means that the first time we do this total, when you try to add it in, this total over here had no value in it, so it wasn't initialized. So we really want to be able to initialize it. The same as we had with the sum last week. So let's try and run it again. Oh, it compiles. I hope it does what it's meant to do. And okay, well, let's say I want flavor, caramel dolce de leche, of course, and I want 3 scoops of it. And I have enough to buy some ice cream. And what happened then? Would you like to try ordering some ice cream? And it wouldn't let me do a yes or a no. It's so rude. Who remembers what I can do to fix that? Line 47. Someone is saying space. Where should I put a space on line 47? Nope. I think someone's got the wrong line. What can I do to fix that issue? What is happening? Why isn't it letting me put a yes or a no? Yeah. Yeah, so scanf is really giving us a bit of an issue. Yes, well done. A space before C. So remember, when I pressed enter, scanf read that enter and said, oh, okay, I'm going to pop that into the loop because scanf, enter is a character. It's a line feed on the ASCII table. So therefore it read it. And remember that the tip for that is to be able to put a space before it, and then it's going to skip the white space. So now hopefully it's not going to be so mean to us, and it's actually going to run. So now if I want 5 scoops of ice cream, it's going to ask me, and then I can go again. And maybe I'll go again, another 5 scoops. And now it's just hating on me. And why is it hating on me? Let's not talk about it. There is a reason for it. And it's to do with scanf and how scanf is just not having a good time. Because scanf is quite, has a few eccentric things to it, especially the way it reads in characters. And we will talk more about that in week 5, I believe. Okay, so we fixed this bad style. It's kind of looking, I don't know, it's looking okay. I mean, it's still not, it's not fantastic, but it's definitely starting to look a lot better. Okay, so there's a few more things that we can do and a few more things that we can talk about when we do our style. Okay, so we kind of did all of these things. It was pretty exciting. Everyone knows we have a style guide. Tom, could you please paste the link for the style guide into the chat? So have a look at our style guide because it will direct you what to do and how to use things and where to indent and what to indent. But basically, write comments where they're needed. So we usually write comments when there's a very complex piece of code and we want to explain it briefly, what that little complex piece of code is doing. Name your variables based on what that variable's there to do. In your block of code surrounded by the curly brackets, you indented 4 spaces or a tab. Line up the closing bracket with a statement that opened them vertically. So exactly as we've been doing when we tried to fix the indentation. 1 expression per line, consistency and spacing. So consistency in the way you use white space as well. I separate out my variables sometimes because it helps me to see what's going on. But just be careful. Too much white space is not a good thing either because it makes your code hard to read as well. So make sure that it kind of makes sense and it's consistent as well. And watch the nesting of the ifs and we will learn how to break them up as well. Someone's asked, do we need to add comments to assignment 0? Well, it's wholly possible to do assignment 0 without and still have great style without actually writing any comments. So based on how well you're going to name your variable names and how well you're going to, actually structure your code. The only comment that you would absolutely need to have in assignment 0 is the header comment, okay? So it's really important to have that header comment in there that says, what is this program doing? What is your name? What is your ZID? Perhaps what is the date? And we give you, in the style guide, there is instructions on what to put in your header comment as well. And there is a rubric as well on the website. So you can check the rubric and you can see exactly what we give marks for and what we take marks off from. No, that didn't work. What we take marks off. No, having a brain fart on how to say that. What marks are given for and where you can lose marks. Let's just go with that. I'm not going to try and do to and from. Okay, so different organizations that you will then go to work for. If you do coding, they will often have their own style guides, but the basics remain the same across, indenting, nice indenting, consistent indenting, the way we kind of do white space, the way we name our variables well, the name we define constants and so on and so forth. Those basics are always the same. There might be just slight differences. So each one of your assignments this term will have style marks attached to it. And we share a rubric for how we mark it with you as well, so that you are able to actually see, where you gain marks and how you can get sort of good marks for that component of the assignment. And I strongly recommend you do good style because it's kind of like an easy way to get marks as well. Okay, so we've talked about the style guide. Okay, some neat shorthand, which we kind of already did because you are all so clever that you were like, what does this do? And then I had to explain it last week. So you are just ahead of the train, I guess. So you can increment count by 1, and doing count is equal to count plus 1 is the same as doing count plus plus. Same way you can decrement by doing count minus minus by 1. You can also do it by 5, and you would have seen someone in the chat, I remember, had something like that and they asked about it. But if you do count plus equals 5, what that means is count is equal to count plus 5. So when we use those sum is equal to sum plus something, you can use this notation because it's basically a shorthand way of saying, the same thing. Similarly for decrementing, similarly for multiplying and for dividing. Okay, so remember how we checked that scanf returns something by doing int scanf return. Scanf return is equal to, and then whatever scanf gave us back, we would put it inside our variable scanf return, and then we would check whether or not, whether or not it's equal to 1 or whether or not it's not equal to 1. So you can actually call functions inside the if statements if they return something that can be checked, and inside your while loops as well. And someone asked this last week. It's so exciting. It's just amazing. So what you can do is you can actually check this statement inside your if loop, which means that you don't need to have this variable if you do it that way. So what that means is that you can actually just call the scanf function in here, and it will scan stuff in, and that will return something. So this will have a value. So I will be able to check what that value is against my numerical here, and then I'll be able to compare them in that if statements as well. Okay, so I just wanted, before we go on our break, I just wanted to leave it by saying that this lecture is kind of like the, I don't know, I would hope that it's a moment of just a bit of reflection to let the last 2 weeks sink in. After this, we start to sort of pick up speed. We start to get a little bit harder, a little bit more complex. So if you don't understand something, please don't panic. It's perfectly normal to not understand something first go, the first time it's explained to you. These are abstract concepts often, so they're not intuitive to us. So sometimes you'll need to have it explained a few times. 3 times, 4 times, sometimes, 5 times. And that's okay as well. So if you don't understand something, try and read over it again. Try and ask questions in your tutorial in the lab. Come to the help sessions. So we are here to help you. So please make sure to ask for help. If you're struggling with your 1-dot exercises, please make sure to ask your lab demonstrator for help, or your tutor, because they'll be able to help you and actually find what is it that you don't understand and explain it to you. So please make sure to ask for help if there is something that you're not understanding, or if you're struggling to do the 1-dot exercises. If you can't solve a problem, break it down into smaller and smaller steps until there's something that you can do. And again, ask us loads and loads of questions. The forum as well is running. There's a lot happening. The help sessions this week are actually going to be on every day of the week. I will announce the rest of the times after this lecture tonight, but they are also available on our website. Tom is about to place a link into the chat, and we have the help session schedule on this website. Okay, so please, you're going to have, there's a lot of help sessions. We run quite a lot of help sessions. So someone's saying, what about the 2-dot exercises? We want you to be able to attempt them at least. Okay, we want you to be able to attempt them, hopefully get some marks for them, but you please ask us for extra help if you can't do the 1-dots. Okay, and I just wanted to again remind you, learning is hard. It takes time. Okay, it's not magic. Solving problems is also hard. It needs practice. So you're building up your vocabulary of different types of problems that you can have, and then you can actually work through them, and when you see similar problems, you're able to solve them a lot easier as well. All right, so on that note, and for those of you that maybe have done Wondrous, I'm not sure if you have, if you've already been in your lab, you might enjoy this exercise or this little riddle, I don't know. But let's take a 5-minute break, and then we'll come back and we're going to look at functions. Hello, everyone. Welcome back. How exciting. Lots of people got what this is and what I was trying to get. If you manage to get a number that does not land you in an infinite loop, you've just solved one of the sort of greatest problems that we have right now. So you'd be pretty amazing if you could. And there is an exercise that kind of plays on this as well. And I've attached a link as well if you wanted to read up a little bit about it. A bit exciting. All right, quick sidebar. Okay, quick sidebar. So I've seen a few messages on the forum where people are perhaps finding this week's section of assignment 0 to be a bit harder and are feeling a little bit down about it. So if you want, what we can do this week is we can organize a little live stream where we will go through some of the problems for assignment 0. I don't know how to, can we,
Done.
actually, Tom, are you running a poll for me?
It's running now.
Excellent. There is a poll running now. Please let me know if you would find that useful and we will do that. So please vote on the polls.
It's supposed to be, there we go.
Here we go. The poll's up. So if you would come to a live stream about assignment 0, maybe half an hour, we will explain to you the whole of the week 3. And that should hopefully, we can hopefully clear up any issues. So if you do have any issues. Okay. Does someone just ask how you get in the forums? Tom, I'll let you answer that. Okay.
Also Slido now.
Yeah. How do I open this to see what the... Okay. So we're now going to do some functions and we're going to talk about functions. So what I'm going to do is I'm going to have a Slido going again to see whether the pace is okay or whether I should go less pace, more pace, faster, slower, or just right. So you can, Tom will put the link and the number into the chat so that you are able to have a little vote. If we have a live stream for assignment 0, it will absolutely be recorded. Yeah, so we try and record everything so that it's accessible to everyone, and so that if you're not able to come, you can still, you can still sort of watch it, but you won't be able to ask any questions live, which is one of the benefits of coming to these sorts of things live. Okay, fantastic. Let's go on. All right, functions. Woohoo! That was quite high pitched. I'm sorry. All right, so let's talk about functions. So far you've heard me refer to printf, scanf, and the main as a function. But what does this actually mean? What where is it at? What does it actually mean? What does it mean to be a function? So who really understands? What do you understand by the word function so far that you haven't learned the definition of it either? What have you learned about functions? What do you understand by the word function? What does it say to you? Jack, for every X there's a unique Y. Yes, I love the maths reference. Thank you very much. Can you draw a vertical line? Input and output, block of code with instructions in it. Something you put in an input and you get an output. Yep. A thing that takes an input and produces an output. Put in something, get out something. Love it. Takes in a value, manipulates it, returns a value. Yep. We have been using functions from day one. Absolutely. Main is one of them. Printf is one of them. Scanf is one of them. Curly brackets. Yes, it does. Chunk of code that does one specific task. Takes an input, produces an output, does a job, gives a value, can be called at any time. Amazing. Everyone's really Yeah, everyone is really feeling functions. A function's a black box where you give it some inputs and it produces some outputs. Yes, fantastic. Discrete maths horror. You input something, process with some rules, and chucks you an output. Yep. Fantastic. It's just a chunk of code. Yes, it is a chunk of code. I love all the maths references. I really do. I do love the maths. The maths. Okay, so a function is indeed a way is a way to break down our code into a smaller functional bit. So what it means is that each function performs some sort of operation, and then each function has inputs and an output, and you can still have an empty input or output, so you don't have to give it an input. We'll talk about that depending on what the role of the function is. And similarly, you don't have to have an output either from that function. And we'll talk about that, what that means in the role of the function. So we can call our function from anywhere in our code to perform its job, and then it will return something to the spot that it was called from. So one other thing actually that I don't have there, but that we talked about earlier, is that what to do if you have a lot of repetition. And that's bad style to have a lot of repetition. So basically, one way to deal with repetition is to make the use of functions. So if you have a piece of code that you're constantly using, one piece of code that's used over and over and over and over again, then what you want to do is you want to pull it out and make it a function, because then you can just call a function each time you need to use that piece of code. Okay, so let's have a look. I think Tom has one maths course that he needs to finish his whole degree. He left them all till last. And now, yeah, you can tell that maths is not his favorite thing to do. Anyway, so don't leave your maths till last minute. Do maths. Maths is awesome. Okay. So what do we need to know about functions? We need to know so much about functions. So here I am giving an example, and we're going to do it in code, don't worry, but I thought I'd quickly run through it before we do it in code as well. So here I've got a function that adds things up, two numbers, okay? So what I've got is, this is the function over here. So it's between the two curly brackets, okay? And I called my function add. So this is the name of the function here. The first thing that you list out is the return type of the function. So what's going to be returned by this function? Now, if I'm adding two numbers together, I'm assuming that what I get back is a number as well. Not necessarily. I might be printing it out in this function, in which case I'd return nothing, but that's another story. But in this case, I'm going to return a number back, which is going to be the sum of the numbers. So the first thing I write is I tell it the return of the function, what it's returning, what data type, then the name of the function. And then in brackets, round brackets, I had a moment where I couldn't think what round brackets were called. I say what I'm going to give this function, okay? So output is at the outside, and then input is on the inside the brackets. I'm going to give it two things, which means that I'm going to separate them by a comma over here. And those two things are going to be two ints. So one data type int here, one data type int here. The first one is going to be called number 1, and the second one is going to be called number 2. Doesn't matter what they're called in there, as long as the data types match up when you give it something. Okay, and we'll talk more about how that works as well as we go. Okay, inside my function, I'm going to declare a variable called sum, and that variable is going to be of type int. I'm going to then say sum is equal to number 1 plus number 2. So whatever is in here is this one, and whatever's in here is this one. And then I'm going to return. Okay, so this is this big return that everyone doesn't like or loves, I don't know. But what I'm doing is I'm returning the sum. Now my sum is an int. So in this case, I'm returning an int because sum is an int. So I can return any number I want as long as I'm returning an int at this stage. So it's basically what I said I would do, and I'm doing it. I'm keeping my promise to this function. So there are a few other things that we can do. Okay, now that I've drawn like this let me just erase all this because I'm going to show you something else that I can do. Okay, so, oh, I don't want to do that yet. Okay, I'm going to go to code. I'm going to go to the code so we can try and do it. Okay, let's try doing it. Okay, we finished with bad style. I'm going to close it. All right, so what I've copied in here into this week's lecture, the functions demo, I've copied our dice checker that we did, I think, in last week. I've copied it in here because it has something called sum in here. So I thought we could demolish this huge thing, and we can take out stuff for functions as well. So I'm going to do my summing outside. Okay, so I'm going to have a function. And then we'll talk about how to call the function as well. Okay, so what I need is the output, and what I need and my input, and name of function. Okay, so what have we got? If we're gonna sum up two numbers, what are we going to output from that function if we sum up two numbers? Yeah, someone's got, I will go through that. You can return a whole bunch of things, not like that, but you can do something similar. Why is it less than 100%?
Truncation. This is a perfect example of why you shouldn't use integers for things.
Yeah, this is, yeah. Amazing. Just a lesson, you know, just right there visually, we've got a lesson.
It's very exciting, isn't it?
It is. Yeah. Just wait, Tammy. You're going strong. Yeah, I love it. Okay, so what's going to be my output on a sum? So if I have this line here, what am I going to be outputting? I'm outputting a sum which is going to be an int. Yeah. So I'm going to output an int. What am I going to input in here? When I add these two numbers in, when I add up the two numbers, they're also two ints. So I'm actually going to give an input of two ints as well. Okay, and I don't know, let's call it sum, because why not? It's called a sum. So again, to write it out, I'll say, what is my output type? And my output type is int, because I'm outputting an integer. The name of my function is called sum, so I'm going to have the name is a sum. And then I'm going to say what are the inputs inside my round brackets. So I'm going to have two ints. One int is going to be called int die1. Another one is int die2. And it doesn't matter what I call them. I could call them something else in there. Okay, curly brackets. Okay, and now someone's asked a really nice question, which is, do I now need to have a variable? You know, I could have int sum, and then I could say sum is equal to die1 plus die2. And then I'm going to return an integer. So I'm going to return the sum as well. But this is quite, you know, here I've done it in one line. It seems a bit weird that now I've moved it to its own function and I'm doing it in you know, 70 lines. Well, it's not 70 lines, in 3 lines, but, you know, let's exaggerate a little bit. Why not? It feels like 70 lines. So, you know, what can we do here? So one of those things is something so simple, but perhaps I would need to use this sort of int sum, or a function that sums up two numbers over and over again. And if I have that type of repetition, I want to have this function. So I'm not just writing this piece of code, but instead I'm actually just writing, you know, I'm calling this function to perform something all the time. So what I can do, I feel like less questions means people have lost me. So please let me know on the Slido if you've lost me or if you're still with me. Okay, so what can we do here? And so someone has actually mentioned that we could do something neat in that you can do a shorthand way And instead of doing all of this here, where I declare a new variable, I add it up, and then I return that variable, okay, what I can do is I can return straight away whatever the addition will be, whatever the operation will be, as long as it matches the return type. So I can just do, instead of these 3 lines, I can say return, and then I'm returning die1 plus die2, which is just going to give me the sum. So what that means is that I don't need to have all of this extra business going on here, as long as I'm returning the right type. Now here, that means that I want to call my function now. So whenever I call the function, if I call one of you, I would call you by your name. That's really creepy. My arm's cut off because the camera's cutting it off. I'm going to stop doing that. So if I call you, I'm going to call you by your name, which is exactly what I'm going to do here. I'm going to call this function by its name. And I'm going to say, okay, I would like sum now, and I would like sum to do something for me. But what I need to give sum something, because what I have said over here is that sum is going to have 2 inputs. Those inputs are going to be 2 integers. So if I'm going to call this sum and ask it to do something for me, I need to give it what I promised I'd give it, which is 2 integers. So if I want to give it 2 integers, I'm going to say I'm going to give it a die1 and I'm going to give it a die2. Okay, so what will happen now is that on line 39, when I'm going to call sum, it's going to go down to this, well, not yet, but we'll see. We'll talk about that in a second. But it will go down here and it will do the sum. It will return a certain number, and what will happen is that number will be returned over here. Okay. Now I haven't stored that return anywhere, which is another situation and a bit of an issue. And also what happens here is I now have a variable called sum, and I also have a function called sum, which is not very nice styling. So I don't really love that. So let's fix that up. I'm going to call this addition for now. Okay, and what I'll do here is, so if I do something like this, then whatever this function returns to me, and it's going to return the 2 dies added together, it's going to go and be assigned to my variable addition, for example. Okay. I'm just seeing anyway, whatever Tom is not responding to, can you just put it on the board, whatever I need to reply to. Okay, so, okay, all right. Okay, excellent. So let's talk now. Yep, about to talk about that. Okay, so what I've said is when I get to line 39, okay, I've called this function here. I'm like, hey, sum, could you please, do some work for me? I don't feel like adding 2 numbers together. I'd like for you to do it. I'm going to go down here and do it. However, what happens? How does C know what on earth this function is? If I put it below my main, okay, remember that C, the way it reads lines of code is consecutive. So it goes, I've read here starting at main, then I read the next line, I read the next line, I read the next line, and so on and so forth. So it goes line by line. So what happens is that we call this sum. If it's sitting underneath here, it doesn't actually know that it exists at all yet, okay? So there is something else that we can do. So one of those things is that you put it above the main function, okay? Now, this is considered to be not very good style. And the reason for that is when you start coding and when C starts reading your code, it starts reading it at main. So if you have 30, 40, 50 functions, okay, your main might be all the way down at the bottom. And that's not very nice for human eyes, okay? Because to be able to find this entry point of code is not particularly fantastic. So there is something else that we can do that allows us to circumvent putting all our functions above the main, which would create some pretty bad style as well. So what would we want to do? We would want to create something called a prototype, which means that we will tell C that there is something coming, there is a function coming, we're going to provide a definition for it, and there's going to be something there, so it exists. We're basically telling C that it exists. And to do that, all you need to do is take the front bit, copy it, and paste it above your main. So your very first definition, and then the only special thing about it is you put a semicolon after it. Now this here is called a function prototype. What that means is you've just told C that something is coming called sum. It's there, it's included, so you can use it. You can use it. Don't worry about it. Don't freak out. So let's see what happens if we don't have it. Okay, so I'm going to comment it out so we can see what it has. Okay, and also I just wanted to mention that this particular example that I have, because I've used a very simple function, I think you're thinking, why on earth would she take that outside of the main? You can just, it's two numbers added together. It makes no sense. The only reason I'm doing it with this particular thing, this addition, is because it's a really easy way to demonstrate what a function is. But perhaps this particular example doesn't quite give you the reason to use functions. So bear with me. You will get more reasons to use functions. Just assume that, summing is too much and we're just learning how to do a function. But you're right. You can easily do this inside the code. It's not really that big a deal. It's more lines almost to take it outside of the code. So we will talk about that as well, because there are a few things that we try as we go through this course. We try and have our main to be only really calling out things, calling out to its helper functions, its little brothers and sisters, because what we wanted to do is we want all of our thinking and happening in functions, and we just call out to functions. And you'll see towards the end of the course, maybe you'll be getting to that point too, but it's something to think about. Okay, if we compile it, just so that you can see what happens if we compile it, let's clear it out and let's compile it. I've forgotten what it's called, functions demo. Demo.c. Okay. Oh my gosh. Who knew that I'd be missing a whole bunch of things, not just the prototype. Okay, I'm missing a whole bunch of brackets, but I'll fix that in a second. But if you have a look over here, what you'll get is this error here. Implicit declaration of function sum is invalid. You're calling a function named sum, but DCC does not recognize sum as a function. Okay, so this is a function that you get if you're missing a prototype. Okay, because as soon as I have this prototype, what happens is now C will know that indeed there is going to be something that is going to work for it. Okay, let me just fix this up. Here we go. All right, here we go. Let's try this again. I don't know if I did. Who knows? Nope. Okay, what have I done? Created a mess. That's what I've done. Well, at least it's not complaining about the function not there anymore. But I've messed up somewhere. Let me have a look. Oh yes, I'm comparing it with sum, but sum is actually a function now. So it's like, what are you doing? What's happening? You can't really do that. So I could use this addition in here, or, so let's compile that. Okay, so now it compiles okay. Or the other way to do it also, remember how I said you can actually call a function inside your if statements and while loops, and as long as it returns something, right, that you can then, use in your expression. So I could also just call it in here and give it, so I can call the function again and give it those two inputs again. But let's not do that right now. Let's not do that. I think I'm going too fast. What's the feel? Am I going too fast? Can you vote on the Slido? Have you lost me or are you still with me? When we call a function, is our other code still running? Oh my gosh, what a great question. This all has to do with the stack and the heap, and I have drawn a picture for it, but I've drawn a picture for it for Friday, not for today. This is a great question. So your other code, function calls go on the stack, okay? So it's going to move on, okay? And whichever function is right on top of the stack, that's the function that's running and performing something. When it returns something, it comes off the stack, and then the next one down is running something, you know, and then when it returns, that comes off. And that's how we control for memory. And I'll draw it nicely with a picture on Friday. I have prepared actually a picture to show you how it works on Friday. That was a really great question. Can you use the function to calculate different variables? Oh my gosh, another great question, because this is part of the reason that we want to use function. So if I have inside here, if I'm just doing my addition, sum is equal to die1 plus die2, that's me done, right? I have to have particular things. But if I'm using a function, I can send it any two numbers to add up, okay? And then it will return something to me. So I can do whatever I like. So functions give me a lot more flexibility. So any repetitive code, I can give it different inputs and get a different output based on, you know, what I need. But it's still performing the same functionality. So let's say I have a function that adds things up, and that's going to be my function there. Okay, and someone said, is sum just a name for the function? Yep, so what happens is, I've lost the mouse, here's the mouse. Okay, this is my return type over here. So the first thing you type is the return type. So this is what I'm going to be returning from my function. Okay, then the next thing you type is the name of the function. So then the name of function. Let me do it better. There we go. Return type, the name of function. And then in brackets, you give it the input type. And input name. And then you might put a comma and you might have more inputs, depending how many inputs you're going to give it. Okay, checking the Slido. Ooh, too fast. All right, let me slow it right down. Okay, let's slow the pace down. Let me take out something else. How about that? And create another function so that you can see me do it again. Yeah. Someone's asked to say, if I have a function which prints one line of asterisk, then I can call the function again inside itself to print the line again. You absolutely can. Should we do that? That could be a simple way to show you what to do. What do you think? Why not? What do you think, Tom? Tom's like, whatever. Do whatever you want. It's Tuesday night. Do whatever you want. Just finish on time. Here we go.
I seem to recall you're the one in charge, so whatever you want.
It's true. All right. Include stdio.h. Okay, let's do a simple function. Let's have a look. So, okay, I'll do one. Let's do my int main void. Okay, and look at this here. Can you tell I used to work at a place that left a space between the curly bracket? You've probably seen me make a space with the curly bracket every single time I've done this. Okay, so if we look at our beautiful int main void, okay, you can see that the int is the return type. And when you remember when we return 0 here, what are we returning? 0 is an integer, okay, which is why we say that we're going to return something, and that's returning an int. Now the void here means that we're not giving the main function anything. And that's true. We haven't given it anything. We're literally just returning something out of it. We haven't given it any inputs. Okay, I'm going to have another function in here. I'm going to show you some, like an addition one, okay? To show you that you can pass any numbers into it and it will just keep returning things to me. Okay, so I'm going to have an int add function. So again, the return type of this function is going to be int. And what I'm going to do is I'm going to call the function add, and I'm going to give it two numbers. Okay, and the numbers are going to be int number 1 and int number 2. Okay, curly bracket, curly bracket. Okay, and what I'm going to do again is I'm going to return from this function number 1 plus number 2. Okay, so this function here is going to be so this function here is going to be, what's it going to be? Int add, okay, and then I'm giving it two inputs, int and int. Okay, so I'm giving it two ints, and then what are we going to have? The name of the function is add, the output is int. Okay, so I'm returning to it number 1 plus number 2, and that means I'm returning it an int. So what I can do is anytime I can print out something, okay, and look at this, what I can do. I can actually call it inside my printf as well. So let's say the first time I add, well, just say I get something, I don't know. Let's do the sum is. This is what happens when I go off topic. Okay, and what I can do is instead of having a variable here, I can actually call the function. So I'll call add, because it's called, function is called add, and I'm going to give it two numbers. I'm going to give it 3 and 7. Okay, so that means at this point in time, I'm going to call a function called add, and then I'm going to give it two numbers, 3 and 7. As long as I give it two ints, it doesn't matter what those ints are. By the same token, I can then continue and I can do it again, except this time I can give it, I don't know, different numbers, 23 and 17. Why not? And it will give it, you know, something else will be the output. So now I've got a function, it's below the main, which means that when I try and call it from here, C is not going to know that it actually exists. So I need to create a prototype. So I'm going to copy this up above the main to let them know that it's coming. And I'm going to put a semicolon underneath it. Not underneath it, after it. To let it know that a function is coming, and this is going to be the prototype of the function. This is what the function looks like. If you put 3 integers in here, you're going to get a little bit of a disaster, because I have told it that it's going to get 2 integers as its input. But if I give it 3, it's not going to like me very much. So let's have a look. Asterisk. Okay, if I run it, it's going to give me an error. It's going to say too many arguments to function call. Expected to have 3. So it will not do bonus adding for me. It will not. It will only add based on what I told it to add. So if I run it again, it compiles. And if I run the program, it's going to give me the first sum is 10. The second sum is 40, because that's what I've kind of told it to do. Okay. But I mean, I can, if I want to be adding 3 numbers, I could, you know, add a third number in here. And then I can return the sum of all of them. So that will also, depending what you're trying to do, and that means all of them need to have 3 numbers now as well. And your prototype has to be matching that as well. So if we save that and we run it again, and then we can run it, and so then it's going to calculate that. So someone was saying now, okay, what happens if I want to print out, you know, a whole bunch of asterisks? So if I'm going to say it's asterisks, and what am I sending it? So each time I do a function, what am I doing in it? What am I outputting from the function, and what am I inputting into the function? So let's think, if I want to print out a line of asterisks, it's a really awkward word to say, asterisk. I've got it. Very slowly, but I've got it. Okay, so here I'm going to call my program asterisk, my function rather. Now I need to know what the output is and what the input is for this function. Okay. Oh, I see there's a whole discussion about what to do with the curly bracket, is there?
Well, I thought that the styles were complained if you don't have the space there.
Yeah. Does it?
It doesn't for that, but it does for if statements and while loops.
Yeah. Okay. Yeah, okay. Yeah, we can. Because what am I giving the asterisk? I'm not even really giving it anything because it's printing out an asterisk. Well done. And what am I returning from it? Am I returning anything? Oh, someone's great. Input could be a number for the amount of asterisk. Oh, I love that. I really do. Okay. Input will be the number of the asterisk. So we'll do int number. So we're going to give it the number of asterisks we wanted to print. And what are we going to return out? Yeah, it might be a void because we can print something out in here. So if the function is void, it means that it's not going to return anything, which means that you're not going to have a return, okay? But if you don't have a return, that means that you need, usually, not always, but it means that you're going to print something out perhaps. So you've put it out to terminal, but you're not returning anything to your main function. And so what we can do in the main function is to call this asterisk. So let's, if we make this call, I'm going to move this out, and what I'm going to do is I'm going to have, let's do this void asterisk int number. Okay, excellent. Okay, so then what do we, so I've got a little prototype of it. This is going to be the function. That's how many asterisks we want to print out. So if I want a certain number, then what will I need to do? What will I need? An if statement? Will I need a loop? Will I need what will I need to do? What do we reckon? Such great questions. All right, while loop. I love it. Okay, so whilst... Okay, we're going to need a counter, aren't we? Because we're going to need to count until we match that number. So I'm going to have an int counter, and I'm going to initialize it to 0. Then my counter, whilst my counter is that less than? Yeah. While my counter is less than number, is it less than? That's less than, yeah. Which way is the crocodile? It's eating the big number. Okay, so while my counter is less than number, I'm going to print f and asterisk. Excellent. Okay. And then I'm going to come back here, and that's, what have I forgotten to do? I've forgotten to do something inside my while loop, something important that is going to cause a little bit of an infinite loop. I do love a good infinite loop, but maybe not right now. What have we forgotten to do? Yeah, excellent. So I'm just going to increase my counter by 1 so that I'm not going to create a beautiful infinite loop and then just call it a day. All right, let's have a look. So let's do, and I'll do a print f, a new line on the new line, because just to see what we've done. Okay. We haven't called our function. So then from the main, all I'm going to do is I'm going to call this function. Now, I call the function by calling it by name, and I've got to give it some sort of number, which is going to be the number of asterisks. So let's do 10. I'm going to give it 10 to start with, and then I'm going to return 0. Okay, let's compile it, and let me actually make this window smaller so we can see the code next to the window. Okay. All right, compile it, run it, and it's now printed out 10 asterisks. Okay. What happens if I then call it again, and I don't know, I'll go 10 more. Yeah. What will happen then? I'll compile it again, and I'll run it again, and now it's going to print me 2 new lines. Okay. Okay. So basically, how does this, what is this doing? What is this doing? I have no idea. Okay, no, I do have an idea. I obviously know what it's doing because I'm making it do something. So basically what we're doing is we're printing out the number of asterisks that we specify here. So we've got a function that's called asterisk, and it's I'm saying, okay, I'm going to call this function called asterisk, and then I want to have 10 stars drawn. I'm going to call them stars because I can't pronounce asterisk one more time, I think. And I'm going to draw 10 stars, okay? So when this function call is made, actually, let me draw it. Okay, here we go. This is what it looks like. Okay, so when C starts reading, we go over here, we see the function prototype, and that tells us, great, there's a function called asterisk is coming. Okay, then we're going to start reading inside our main. So we start reading over here, we'll go down over here, and here we've called something called asterisk, and we've given it an input 10. So once we've called it, I'm going to go and look for it. Here it is. Here's my function. So I'm going to go down here and call it over here. So what happens is the main is paused. Okay, it's not running right now. It's like in the background, but the asterisk is what's running now. So it's going to say, okay, counter is equal to 0. And what I've given it is this number over here, which I've used over here. That's equal to 10. So my counter is equal to 0 right now, which means that this while loop is going to say, okay, is 0 less than the number 10? Is it? Yes, it is. So I'm going to print out one single star, and I'm going to increase my counter. So that means my counter is going to become 1 because it was 0 before. Great. So I'm going to go back to my while loop, and now I'm going to say, is 1 less than 10? Yes, it is. So I'm going to go in here and print out another star. And I'm going to increase the counter again, so now it's going to be 2. So I'm going to go back here and test, is 2 less than 10? Yes, it is. So I'm going to go back in here, print out another star, and so on and so forth. So I'm going to keep printing stars until it reaches 10. When it reaches 10, this while loop is not going to be true anymore. So when it's 10 is less than 10, that's not true. So I'm going to come out of the loop. I'll be able to exit the loop, and that means that I will do this thing here, which is print out a new line. Okay, so once I've printed out a new line, I finish this function. When I get to this end curly brackets, that means I've finished the function and it's over. Okay, so this is now gone, and I go back to my main to the same spot, and then I move down, and oh, I've called it again with the new number 10. So this function is called again, so I'll go back down and start again with the new number as well. Okay, and then I'll go back down again, and I'll print F again, a new line, and then I'll return here, and I'll go to the other line, and it says return 0. And that means I finish running, and this last curly bracket means kill all of that, so free up all that memory again. Okay, so this void here, right at the start, means that I'm not returning anything. And you can see that I'm not using the keyword return anywhere here, because I don't really need to return anything. What I'm doing is that I'm just printing stuff out in this case, which means I don't need to return anything. So that's why there's a void there. So you use void if you're not returning anything, and you don't have to return anything. Oh gosh, what happens if we type asterisk 10 after line 19? All right, we're starting to go recursion, are we? We're not going to talk about recursion, but you get something called recursion. I don't want to do recursion. Well, I do, but I don't. And someone's asked... Okay, so... Thanks, Tom. Okay, and so are variables in main accessible everywhere? No, they're not. Okay, so variables live and die inside curly brackets. By the way, if anyone interested, the aircon is definitely off. Okay, so what happens is if I said this counter here, if I set it inside, let me erase actually, because otherwise I've overcommitted here and you can't see anything I'm drawing now. If I moved this counter into here inside my while loop, what it means is that I wouldn't be able to use it outside of this while loop. So the variable lives between the curly brackets, okay, and then it dies. What I'm giving to, when I'm giving my function asterisk this number 10 here, what happens here is it kind of copies it across into this variable here, the input that I'm giving it, okay? And so that's how this number comes to be, is that I've given it a 10 and it's going to copy it inside here. So it's like a copy of it. I'm not modifying the variable inside the main. And we'll talk more about that. Don't worry, we will talk more about that next week. It's all okay. We will talk more about it. If you had two functions at the bottom, you can have as many prototypes as you want up here. Depending how many functions you have, you can have 10, 20, it doesn't matter. And you can call those functions, not just from the main, you can call a function from another function as well. How's that? How's everyone faring? Oh, too fast. Okay. We're going to go through all of this again on Friday. Don't worry. Oh, someone said you can pass an actual variable with an and. You're a little bit ahead of time, but yes, you can do magical things with the and. You can really work hard. You can really, access memory locations. You will. Is this something you should consider using for assignment 0? No, please don't do it. You don't have to do functions at all in assignment 0. Absolutely not. If you want to practice moving something out in assignment 0, feel free to do so. But if you don't want to practice, don't. Just do everything in the main. The reason we don't do everything in the main is when you start doing really, really difficult programs or complex programs, what happens is you get, 1,000 lines in your main. It's not very easy to read. It's not very easy to understand. So functions help us to decompose our code and break it up into smaller steps. And also they allow us to be able to actually, make calls from the main, have a short main, and then have a lot of helpers. So the main, all the helper functions help our main out. So what does void do? Again, void means nothing. It's a void. It's, black hole. You haven't given it anything. Okay. So the void in this case means I'm not returning anything. I'm not returning anything. And the void here means I'm not giving the main anything. So I'm not giving anything at all. Oh, I'm sorry. The second hour of the lecture is the devil. I'm sorry. I didn't mean it. I didn't mean for it to go downhill. I did give you a little warning right before the break that it's all about to go downhill. I set the expectations. Don't worry. We're going to go through it again. This is just the first intro. I wanted you to hear what a function is. So I am actually going to let Tom speak for a few minutes about Hail. And then I'm going to give you the link to do some feedback for the lecture. Don't worry, we're going to go through it again on Friday before we start arrays. Yay, arrays! Yay! Yeah, and look, like as Tammy said, it took her a long time to get while loops and functions. It's true. It's like, my first computing course, I didn't do very well at all. I didn't understand what was going on, okay? It was all moving just a little bit too fast. You need time to process, so don't worry. Sometimes you will not understand what's going on the first time I explain it. I will explain it again. Just let me know in the feedback as well that you would like for me to explain it again. Arrays were some functions. No, arrays are an angel, okay? They are just... They're just a set of homogeneous angels that just come together to sing a song. You will love it. Arrays make life so much better. They're all the same, these arrays. Okay.
You feel like you got a raise?
Stop.
This is why I'm not allowed at the lectures, unfortunately.
All right. Here we go. Tom's just going to talk about Hail, and then we will do some feedback. I'm going to step out of the camera.
I'm going to step into the camera. Hello. Oh, wow. I have to squat. I'm like squatting right now. This is Sasha's strategy to try and make sure that I finish this quickly. So
I was wearing heels.
Sorry. Okay, we're going to do a very fast walkthrough of Hail because I don't think my physical fitness is up to doing it for much longer than that.
I wish I could take a photo of this. Oh, I can. This is going to go on the...
Okay. Alright.
Great, Tom.
web.unsw.edu.au/ds1511/22t1/hail. Okay, so what is Hail? Hail is our fast pass booking system. That raises the question, what is a fast pass? Basically, in the past help sessions, there were really long queues, and we wanted to try and find a way to make to make help sessions like be easier to come to and be easier, faster to get help. This is how we're trying to do it. So basically, I'm going to log in now. I'm logging in as Sasha, whose ID is lots of 5s with a very secret password. Okay.
Your head's in the way.
Sorry, my head's in the way.
Just move your head to the other side. Press the right-hand side camera.
Right-hand side camera, where's that?
On the bottom. No,
I see.
No. On the bottom. Just the slide. Yep.
Okay, we did it. All right, cool. So, don't save that. This is what Hail looks like. You can find a link to Hail in the announcement that was sent out this morning. Basically, what we can see is that there's a list of events. These are all help sessions at the moment, but there might be some labs that we'll put onto Hail as well. Hey, look, here's a help session running on Thursday at midday. I want to sign up for that. All you need to do, press the sign up button, and you'll get given a fast pass. Now, it's important to note, some people might get given times to arrive after the start of the help session. If you arrive at that time, rather than at the start of the help session, you'll probably get helped faster. Make sure, though, you must arrive before this time, otherwise we might not see you. So please make sure that you are arriving before that time. Now, it also is worth noting that you can only have one fast pass at a time. So if I try and grab a second fast pass to sort of stack them up, unfortunately, you'll only be able to have one at a time. The last thing which is worth noting is that you don't need a fast pass to come to a help session. You can still go to a help session even if you don't have one. You just might have to wait a little bit longer. And if, because we're really busy, we're not able to see you, you'll just have to go and get a fast pass to get seen again. If there are any questions about Hail, you can chuck them in the comments and I'll try and answer them. We'll put a link to Hail as well in there. I think that's it, and my legs are starting to get sore. Sasha, would you like to come back?
Yeah,
My plans for a coup are overrated.
well, it's awkward because I'm wearing heels and Tom's a lot taller than me. Everyone's a lot taller than me. If you see me in real life, and I will start lurking around labs, you'll, all of you will probably tower over me. I look about 12 in height. Not obviously my shirt's older than 12 years old. So, okay, let's have a look. People are saying, are these face-to-face or online? We're going to be mostly online, but we will let you know if we do a face-to-face, one as well. All right. Well, we are at the finishing end for today. Don't worry. We will go through functions again. We just had a quick brief intro to them. We will do them again. Don't worry. So if you have any feedback at all from the lecture, please let me know on that link. I did take a photo of Tom just trying, I've got to post it on the forum. I'm sorry, Tom.
No, that's fair. That's
it's
very
got to go.
reasonable.
But just I don't know, that was pretty good exercise. Just making sure that all my tutors stay healthy. I don't want anyone to be unhealthy. There we go. All right. I hope you all have a wonderful evening. There is a help session on today.
I was going to say, we look from the books of the poll. We're going to try and organize an Assignment Zero live stream. I picked out a time, but we'll check it with Sasha and then we'll post it on the forums as an announcement. It might be tomorrow, so keep an eye out for the announcements, but we'll let you know as soon as we've got details.
Yeah. So thank you, everyone. And yes, sometimes you will be confused after a lecture. Do not worry. We will go through things again, and that's why we have the tutorial in the lab there as well. So thank you, everyone. Have a great week. I look forward to seeing you on Friday. That's our party lecture. That's where we play party music, I guess. Maybe we'll see. But thanks, everyone. We'll see you Friday.